Today, we are going to start with quadratic functions. In quadratic functions, we are going to look at two main things. First, we are going to analyze graphs of quadratic functions, and then we will learn how to write the quadratic functions in standard form and use the results to sketch the graphs of these functions. So let's start with what is a polynomial function? A polynomial function is a function which is given by this expression of an equation, fx equals a sub n x to the power n plus a n minus 1 x to the power n minus 1 dot 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 plus a2x squared plus a1x plus a naught. Now this is called a polynomial function of x of degree n. This degree n comes from the degree, the power here, you see. Now this is of degree n provided the coefficient a sub n is non-zero. These concepts, guys, very important. The a sub n has to be non-zero for this function to be a polynomial of degree n. Also, the variable here is x. Okay. Then the coefficients, or basically we call the constants or real numbers. They are a sub n minus 1, dot dot dot, a sub 2, a sub 1, and a sub naught. And this n, guys, very important in our polynomial function, is a non-negative integer. Remember, non-negative integers means you can have 0, 1, 2, 3, so on. Okay, so once more, the polynomial function of a degree n is an expression of this form: an xn plus an minus 1 xn minus 1 dot and then a1x plus a sub naught. It will be of degree n if the highest power has a coefficient to be non-zero. That means a sub n is non-zero. So let's look at some types of polynomial function. The most simplest one is a constant function. It's a polynomial that has degree 0. For example, fx equals a, where a is not 0, a is a real number. Let's look at a nice little simple example. Say fx equals 3. Now, that means no matter what value you throw in the domain, x, remember, is the domain or the input of the function, and the value of that function for every input is going to be a 3. And how does a graph looks like? Remember the xy plane. So this is my x, this is y, and 3 is a positive number. Remember, on the number line of the y-axis, numbers as you go up are positive. So what is y equals, fx equals 3 or y equals 3? This is the, and the graph, as we say, of a constant function is a horizontal line. Now the famous linear function, guys, we are so used to remembering y equals mx plus b. Remember that? That's a linear function. Now it's called a polynomial function which has degree 1. It's written as fx equals mx plus b. Very important, m is non-zero. Okay, and also this m represents the slope, and the y-intercept is the point 0 and b. Remember, intercepts are points. Keep this in mind. Intercepts are points. Okay, so let's draw a linear function. The graph, as we say, is a line. Suppose I have this graph. So this is basically, say, y equals, now it's going up, that means a positive slope, say x minus 2. This point is given as 0 and minus 2. Okay, let me just write that nicely here. Oops, I lost the line. That's okay. We can make the line again. And this is minus So this, guys, is the y-intercept. And the slope is 1 over here. Okay, so here from this equation, m is 1. Okay, as we said that in this session, we are going to be talking about quadratic functions. So what is a quadratic function? A quadratic function is a polynomial function that has degree 2. It is written in the form fx equals ax squared plus bx plus c, guys, here. A is non-zero and the coefficients a, b, and c are real numbers. The graph of a quadratic function is a parabola. Let's look at, say, a very simplest example. Fx equals x squared. And this is our famous U-shape called the parabola. We have looked at this in our previous chapters. Okay, so let's look at, we all know the graph is a parabola, but there are certain characteristics we would like to talk about. So that's the next slide we are looking at. Okay, suppose this is our function ax squared plus bx plus c. Now over here, notice the leading coefficient is a. The leading coefficient is the coefficient which is the constant term multiplied to the highest power of x. So here the highest power of x is 2 and the coefficient of x squared is an a over here. So if your a is positive, that simply means the parabola will open upwards. On the other hand, when this a, which is called the leading coefficient, is negative, then you have an upside down parabola. Okay. Then we can also learn now the vertex. This vertex is important. When you have a parabola opening upwards, the vertex is the lowest point of your quadratic function. And it is at this point where the graph of that axis passes through. It's this vertical line which passes through this point. This is called the axis. The vertical axis is the line where the left-hand side of the graph, when you fold it, exactly meshes with the right-hand side of the graph. So, or in other words, we say that this axis basically divides the parabola in two equal parts. So what is happening over here will be happening over here. So that's what this vertical axis is. Now, in the language of mathematics, what do we call? Let's look at that. Now, the graph of a quadratic function is a parabola, we just said. All parabolas are symmetric with respect to a line called the axis of symmetry. For example, in our previous slide, we looked at this simple expression. So this y-axis here is the axis of symmetry. Okay, this is the axis, and this is the point which is the smallest, or it is the smallest value you can have. So the vertex is the minimum point. When you have a graph like this, let's make it a simple graph x squared. Now remember the coefficient is 1, but this 1 is positive, the graph opens up. Now let's look at, now here we also say the point where the axis intersects the parabola is called the vertex. And we see these parabolas in many real-life applications, especially when you talk of satellite dishes, flashlights, reflectors, and all those things. I would also like to talk about a parabola which is facing downwards. So let's look at this. Suppose I had a parabola which was minus x squared. What does that mean to us? It means you're going to flip this U shape and your graph looks like this. Now in this scenario, guys, remember the vertex is the highest point of your parabola. And this again, this vertical line is the axis, and the vertex of this parabola is the highest point. Now remember, vertex is a point. It will have a 0, it will have two values. So in this point, it's 0 and 0. Here again, the vertex is 0 and 0. Okay, now let's concise all the things we just talked about. Now the characteristics. If your graph of the function fx is ax squared, a is positive. Domain means what values my x can take. X can take anything. Whereas range, look at this one. The graph starts at this x-axis and then it goes endlessly upward. So the range is the values where your y is taking. It will include the value 0, but then it is positive. Okay, that's the range, guys. When you look at the y-axis, that's giving us the range. Intercept. Intercept is where it is crossing the x and the y-axis, and it crosses only at the origin. And this is the minimum value of your parabola. Also, this is the vertex. That's 0 and 0. Now, also, this is increasing on the interval 0 to infinity. Remember, 0 to infinity, what's happening? It's going up, up, and up. But when from minus infinity to 0, the graph is going down. Okay, the axis of symmetry. This y-axis is called the axis of symmetry. This is the proper way to represent this y-axis. Because every point on the y-axis, the x coordinate will be 0. Okay, now let's look at the function ax squared when a is negative. Clearly, the domain means what values my x can take. It can take everything from here on the x-axis. That's the domain. The range now. The range, notice it. Where is my y looking? Where is my y values looking at? It starts from negative infinity and it goes till the maximum 0. That's the intercept. That's also the vertex. Remember, that's the vertex, that's the intercept. But in the upside down parabola, the vertex is the maximum value. Now, it is increasing from minus infinity to 0. Remember, you see the graph going up. But it is decreasing from 0 to infinity. It is an even function. Now, remember, what's an even function? Even function is if you replace the negative value, if you replace your x, that is the positive values of x, by the negative values of x, the output will always be the same. That's an even function, guys. Okay. Now, let's actually do some examples. And when you look at these examples, what you're basically doing is we are going back to our previous chapter where we learned about transformations. Okay. So let's look at this one. We like to sketch the graph of each of these functions. There are 3 of them by hand. And we like to compare it with the graph. Now remember, if you from your previous chapter, this is called the parent function. And the parent function is what is now moved down, moved up, flipped, all these things. The horizontal movements, the vertical movements, all those things of the transformation comes into play here. Okay, so let's look at this graph of this parent function. This is our graph of the parent function. This is fx equals x squared. Okay, now what does the function gx do? This function looks at the parent function and says if this whole parent function will now go down by 3 units. That's what it means. The output will not decrease by 3 units. That's what's going on. So let's go ahead and draw the graph. So remember, this new graph is just, remember, this is the vertex for the parent function 0 and 0. The new vertex would be now 0 and minus 3. And just basically eyeball this. The shape will not change. It will just move down by 3 units. Okay. Let's look at this minus x squared. Now what is happening? Minus x squared, remember, we just talked about, it is flipping the graph. So here, first of all, when I would draw the minus x squared. So this is the graph of say f1 of x minus x squared. this original parent function has been flipped across the x-axis. But the function which we are looking at is not only it flips, but it also goes upward by 1 unit. So the graph which we are looking for, this h of x, is nothing but the same graph, but it has now moved up by 1 unit. So this is the new vertex, which is 0 and 1. And this is the graph h of x, which is equal to minus x squared plus 1. Okay, now let's look at this another function. We have, say, h of x. Okay, what is happening over here, guys? Look at this. This is called the horizontal movement. Here the graph moves to the right by 2 units. And then the graph moves up by 4 units. Okay, so let's start with the original graph and then we basically create this graph. So this graph is my parent graph, say fx equals x squared. Then what happens? In the next one, we are now going to, Okay, let's just move on this side so you can see everything. Now then the next step we're doing is we're moving the graph, this parabola, to the right by 2 units. Okay, so what happens now? The new vertex is at 2. Okay, so this one is the graph, say f1 of x equals x minus 2 the whole square. Now the final graph you're looking at is it is moved up by 4 units. So what is the final graph? The final graph is the new vertex. Now remember, this is the vertex which was 0 and 2. Sorry, 2 and 0. And now it moves up by 4 units. So this is, let me draw a nicer looking one and I need more space. So let's do it here. Okay. So this is, say, 4. This is 2. So this is the graph. So this is the coordinate 2 and 4. And this is our new graph, the one which we were asked to sketch. This is the graph hx equals x minus 2 the whole square plus 4. Okay, so that's where I will stop, guys. And in the next session, we are going to talk about different forms of quadratic function, how to solve them and how to make them also. Thank you.